Hey, what is your everybody? Welcome back to the channel. In today's video, we are going to implement our very own file system. So we are going to make it very small. It's not going to be complicated, and most importantly, it's not going to be too platform specific, if I may say, right? So what is a file system, and what do we want ours to do? So our file system, we want it to be able to allow us to basically read a line, a single line, which is here, right? And then after reading that line, we want the ability to then be able to be like, okay, now read the second line, okay? And then just keep on reading another line, another line, another line until you reach the end of the file, okay? So that is what we want. Oops, what just happened? Sorry about that. So that is what we want, right? We want it to give us that ability to essentially read a file line by line. And the benefits of this is that, for example, if you were maybe coding your own, I don't know, metadata file system situationship, right, that allows you to essentially just define some stuff and then basically some configurations and then basically load that up in your engine and then parse that and then do whatever that is that you need to do. And then reading that file line by line can be useful for parsing essentially, right? Because then you can read this line, parse it, and then tokenize it, and then do whatever it is that you want to do, and then read the second line, parse it, tokenize it, and then check for any errors, and then continue to go on and so on and so on and so on, right? So that's the one benefit for that, right? Reading line by line. And then let's say, for example, we don't just want to read a line by line now, we just want to read a chunk of block of memory or data from this file. Then we can basically just be like, okay, fine, file reader, I want you to read this block of data from this position and then all the way to this position, right? Or instead of starting from there, we can just start from here, and then I want you to get whatever it is between this range, okay? We can do something like that as well. Or instead of just doing that, we can just have the file reader just load up the entire file for us, and then we can just do whatever it is that we want to do. For example, if we had shaders, for instance, this is where loading the entire file can essentially just work for you. And then you can just load up the entire shader and then compile it and do whatever that is that you're going to do. And for teaser, our shaders, we're going to do runtime compilation. So this file system will definitely be used in that system to essentially load up the shader and then compile it at runtime, and so forth, right? So yeah, so anyway, now that you know what we're going to be doing and what our file system is essentially supposed to do or allow us to do, let's get on and let's code it. So in our project, let's go down to the engine folder, and then inside the source folder, let's see, do we want to put this in the platform? Now, you can put this in the platform because it depends on your specifications for your file system. Do you want it to be platform specific? Because a file system essentially can literally be platform specific, and I would recommend that you make it as platform specific as you can. But if you're trying to go cross-platform and all of that stuff, then you don't have to make it platform specific, and then you can just sort of like make it generic in a sense that you don't have to, have different versions of it on different platforms. So for our case, for this series, I'm going to try not to make it too platform specific, or not make it platform specific at all. Just a teeny weeny, I guess. I can make it a teeny weeny platform specific, but not too much, right? You'll be able to just use the same technique that I'm using on Windows, Linux, or any other operating system that exists out there, I suppose, because you're going to be using the C language and the C way of opening files and closing files and reading files. So that is basically supported on any machine. So yeah, we're not really gonna make it too specific. So I'm not gonna put this in the platform. So I'm gonna think about it. For now, I'm just gonna put it in the utility folder. So I'm gonna create a folder called utils, and then in the utils folder, I'm gonna create a folder called FileSystem.h, and then I'm going to create another one called FileSystem.c, and then from there, in the H file, we're just going to do a pragma once. I'm going to save that, and then in the C file, we're just going to do an include FileSystem.h. I'm going to save this. and then I'm going to close these two files, and I'm going to go down to my main.c, and then up here somewhere I'm going to include that file system. Okay, so utils and then FileSystem.h, and there we go. Right, so I'm going to save this, and then I'm going to just compile everything and just make sure that everything is working. And everything is working indeed. So let's go around to the H file system file, a header file, and then in here we're going to define our struct and our functions. So let's create a type def, and we're gonna have enum. I'm gonna call this an enum, and then these are gonna be the file modes. So I'm gonna do file mode like this, because when you open a file, right, using the C way of opening files, you need to pass in the mode. Do you want to read it, or do you want to write to the file? Do you want to read the binary, or do you want to write a binary, right? So those are the different modes that you can have. So in this enum, that's where we're going to define the modes that we support. So we're going to support the mode read, then we're going to support the mode write, and then we are going to support the mode read binary, and then we're gonna have the mode write binary. Okay, like so. Okay, these are the 4 modes that we can do, that we can support or will support. And then I'm going to create then a type def struct. This will just represent a file for us. Hopefully this won't conflict with any C definitions, I hope. But then this will be our file, and then our file will basically have like a void pointer handle, because this will be retrieved from the cfopen function. You'll see in a bit. And then we're gonna have a function, an optional variable here as well. And then this, oh, did I just say variable? Yes. And this one is going to just be the path of this file. You don't have to, but I'm going to show you why you can have custom data in the struct. Maybe you can also have one for, is the file valid, is the file invalid, etc., etc., right? So for now, we're just going to have this. Just keep things simple for now. And then just close this off, and then after that we can then define our functions that we're going to use. So we're going to create a boolean function, and we're going to call this file system file exist, right? And then it's going to take in the const char path of the file that we want to check if it exists or not. And then we're going to have file open like so, and then we're gonna have actually, yeah, file open, wait, hold on, exist file open, yes. And then to open the file, we're gonna pass in the path, and then the mode that we want to open with. So file mode, and then we're gonna also have the file, right, the file handle that we want to populate once we open this file. And then we're gonna do file close, and I think here we just pass in the file handle, and then we're just gonna be like file like so. Okay, and that's about it for these. So we can basically check if a file exists. Then we can basically open a file, and then we can also close a file. And then next, what we want to do is define another function that will then allow us to be able to read a file by line. So we're going to do file system read line like so. And then this one is going to take in the file handle, so a file handle. And then it's also going to take in a U64, and then it's going to take in the max length, and then I will explain it a bit. And then it's going to take in the char, and then this will be the buffer, so the buffer to store the line that we just read 2. I guess I can just annotate it with an L here to indicate it's a line buffer, right? And then we can go ahead and be like, what else do I need? We need the U64 out line length. So if you want to keep track of how long that line was, the size of that line, then you can basically keep track of that as well. And then the next one that we want to do is write. So we want to read a line, and then we also want to write a line, and then we're going to pass in the file. And then instead of all of this, all we do is pass in the stuff that we want to write. Right, so in this case it will just be text that we want to write to that line. And then I think we are fine. And actually I want to add another function here. I'm going to call this one FileSystem get file size. We want to be able to get the size of the file as well. So I'm going to do file. I'm going to pass in the file handle, and then we're going to do 64. This will be the size that we basically going to be giving out to the caller, and then you guys can basically do whatever it is that you want to do once you get that size. And then yeah, so we're going to be getting the file size, read, write, and then what else do we want to do? We can read the line, we can write a line. I guess we could also add the ability to read, like maybe just a chunk of the file or something. And with that, we'll just do FileSystem read, and then we can do the file handle, so file, and then we can do a U64. This will be the data size that you want to read, and then this will be the void out data that you've read, and then also the bytes, the amount of bytes you've actually read. You can use this to essentially check if the amount of bytes matches the size that you basically wanted to read or whatever, and then see if that matches, then you've basically read the amount that you really wanted. If not, then you've read something else, or you've missed something, and you could do whatever it is you guys want to do with that information, right? So that will be a U64 that's pointer, so out bytes read, and then I think this is it. Okay, so we can take in the file, pass in the size, the data, give you out the data that you basically read, and then the amount of data you've actually read. And then what we're gonna do is do a boolean file system read. We can also do a read. Now this doesn't read the entire file, by the way. So this function that I'm going to code actually reads the entire file. So read all. Now, yeah, read all. So in fact, let me just separate the two. Let me say read all bytes instead. This one will just read all the bytes and give us the bytes, and then we'll have another one to read all text. So let's just pass in the file handle that we're going to use to read from, and then essentially we just want the out byte, so that will be a U8 pointer, and then just say out bytes, and then we're going to have a U64 and then pointer, and then this one will be out bytes read, and that's about it, right? Yeah, and then we can just duplicate this, and then instead of bytes here we can just say text, and then we can do out text, and this can be a char because we're storing text now. So and then the out bytes still the same thing, it's just how many bytes you've actually read, and then that's it really. This is all we'll support for now. You guys can go deeper if you want, but I think this is it for me. Yeah. Okay, so I'm gonna copy all of these functions, and then I'm gonna go all the way to filesystem.c, paste all of this, and I'm having an error message here. Unknown U64. So let's go back and actually include, let's say platform / defines, and then let me see. Yeah, I think that should get rid of that, right? Yeah, it did. Okay, sweet. So let's start and filling this out. Now, to check if the file exists, what we're gonna do is gonna use a technique that I think we've already used before. I'm not quite sure, but I think I've already used that technique before, and I believe it had to do with how we load. Oh, it had to do with this. Where is it? File info. Yes, right here. Right. Is using this technique. So we're gonna use the stat, and then we're gonna get the file information, and then from there we're just gonna see if that file actually exists, using the sysstat header. So let's go back into the C and then just include that. So we're gonna do sys. I guess it stands for system, but yeah, just do sys and then do stats, and then once you've done that, can use whatever is inside of that header. In this case, we want the stat, and then we're gonna call this the file info, and then double hold file information, and then all we do simply here is just return stat, which is going to give it the path. It's going to take in the path, and then it's going to take in the struct or to fill. The struct to fill, in this case, we want the file info. This will just store file metadata to that, and then all we can do is do this. We can just check if it was successful, right? Because if it's not successful, then obviously the file doesn't exist, right? So if it fails to get the file metadata, then obviously that file doesn't really exist, and then it will return true or false based on whether it succeeded or not. Okay, and then that's it. That's a fairly simple function, and yeah. So now let's do file opening. Now, I'm not sure how cross-platform this is, but it should be cross-platform enough to use on Linux and Windows. I think maybe Windows probably have to annotate it with this, prefix it with that. I'm not sure. You guys can just do some research on that, but this works on Mac, so I'm going to use it. And then the file opening. Now, I was doing a little bit of research here. You can see here they're passing in R, so that's the mode that basically means that we're opening this in read mode, and then you could replace that with a W to basically read that in write mode. I'm not sure. I guess I closed it. I guess I closed it. Let me see if it's not here. There was a table that essentially showed the different read and write modes, but anyway, it's fine. I still remember them. If you guys can hear my housemates in the background, I apologize. They are screaming right now. But yeah. Alright, so anyway, this is the modes that we're gonna handle first. So in here, I actually wanna do this out file. Remember, we added another variable in here, the path. I'm gonna set this to equal to the path that we're passing in, just so that we can keep track of it, because there's a place where I'm gonna use this, and I'll show you guys later on. Okay. But anyway, back to the file read modes. I'm gonna basically filter out this using a switch statement. So I'm gonna do switch, and then in here we're just gonna say mode. Right, and then I'm just going to take all of this out of here, and I'm going to say case. I'm going to do file mode. Let's do read first. So in case we're just reading, then I guess we can, I'll have to basically create a variable here. So let's do a const char. This will be a private variable, so I'm going to annotate that with, I'm going to prefix it with this, and then just type mode, right? Just it's the same name as this, but it just has that guy here. And then that's the one that we're going to use to populate. So we're going to say mode equals to, if it's in read mode, we're just going to say R, right? That's just indicating that we're just reading, or we're opening the file in read mode, right? So we can't really edit it, I suppose. Yeah. And then, what is this? Enumeration, not handle. Oh, we still need to handle all the others. So I'm curious if this can actually populate it for me. No, it can't. So we can just duplicate these, I guess. And then this one will be read binary mode. So then you just do RB, like so. And then this one should be write. So then you just use a W there instead. And then this one should be write binary, and then it should just be RB. WB, I mean. And then in a case that for some weird reason, somehow, I don't know how, you just passed in an invalid mode, we'll just default to just read mode, okay? And then we'll just say R, and then break. Oops, like so. Like so, yeah, okay. Default, like this, I guess. And then what's this complaining about? Value is never read. Okay, yeah, we now need to use that. So we're going to use it here. So you can see, to open a file in C, all you do is just use this one line here. So that's what we're going to do. We're going to say file, and I don't have that. So I think I need to do include stdio. This is an stdio. Yes, it is. So you can say file with all caps. So this, I guess, is not the same as our custom file. Ours is lowercase, and theirs is full capital letters. All right, so do not confuse the two. And then this will be a file, and then we can say fopen, and then we can use the API. Here it wants the file name, and then the name is basically just given by the path, and then the mode here, we're just gonna pass in the mode, and then that's it, right? And then it says what it's never read, so probably we might want to check if it also exists or not. So we can check if the file does not exist, or if it failed to open, then we can log to the console, and I need my logger, so let's do include it is inquire logger. Let me just put a space there, and then we can say log error, and then we can just log an error message and be like error opening file, and then we can just give ourselves the name of the file that we want it to open, and then we can just say path, right? That will give us the file that we want it to open, and we can just return false here because it failed. So let's do a return false, and then in case that the file did successfully get loaded up, all we can do is just populate the handle, and then be like handle equals to this file. Okay, so we can do file, and that's how our API works. Okay, we're just wrapping around this. Okay, and then once we're done, we can just return true, and from there we're done. So that's it. Okay, and then what we do is we can do the file close, I guess, right? Because after opening, we need to close the file. So what we're going to do is just going to check if the handle does indeed exist. So we're going to check if the handle exists, and if it does exist, all we're going to do is just say fclose. It was fclose, yeah, fclose. And then we can just pass it the handle. We have to recast this back to this data type, because for us it's a void, so we're just casting it back into this, and then we're saying file handle, like so. And then it should just close the file, and then we just want to set our handle to nothing, so we just say handle is 0, and then we can return true because we managed to successfully close. But if the file handle doesn't exist, so there is nothing to close, so we can just return false. Return false, like so. And that's it. It's pretty simple, right? It's really simple. All we're doing is just wrapping this up into its own function call. And then after that, we need to have a way to get the file size. Now, I think let's do how to get file size in C. I think what I used was here. Okay, yeah, use the seek and the tell. Okay, so that's what we're also going to use. We're going to seek to the end of the file, and then we're going to get the size, and then after getting the size, we can close. But since the close is basically abstracted into its own function call, we handle that separately. So in this file, we can use the C way of getting the size, which is what I'm going to show you how to do. So what we want to do is to do a check first to see if the handle does indeed exist. So we're going to do file handle, and if it does exist, then we basically want to fseek, right? We're going to pass in the handle. We're just going to cast it to the file because it needs the file, and fp for them is it's the file. So we casting to that, and then all we're doing is saying file handle. We're just casting it to that, and then we want to basically pass in the what is this delong? What did they do? Seek. Okay, yeah, I'm just gonna start at 0, and then we're gonna seek to the end, like so. Okay, and that's it, right? So we seek to the end. Once we are at the end, that's where we can basically get the size, right? So we're gonna store that. They stored it in the long. For us, we're just storing it out size there. So we're gonna do out size equals to what was that? ftell. Okay, so I'm going to do ftell, and then we're just going to give it the handle. So we're going to file, cast this, file, handle, and that should just give us the size, right? Yeah, that should just give us the size. And then once we have the size, remember now, here we seeked to the end. Here they also seeked to the end, but they don't seek back again. So it will just be safe for us to just rewind and just go back all the way to the beginning of the file. Okay, so we're just gonna rewind, and then do file, just say file, handle, just rewind all the way back to the beginning. And then once we got the size, we can return true because we managed to get the size. But however, if the file handle did not exist when we call this function, we can just return what is this? False. Now, this is the C way of getting the size of a file. You basically open the file. It requires you to have the file opened, and then you seek to the end, and then you get the size, right? And then you can rewind if you want, and then that's it, right? Now, there's another way using the sysstat method. All we do, just like we checked if the file exists, we just take a struct, right, a variable, to populate with the file information like this, and then all we do is say stat. Then we give it the path of the file, and we stored that in path here. And then all we do is just give it the struct to fill with that metadata, the file information. And then once we have that, we can just do out, like out size equals to file info dot size, like this. That is the same thing as just doing this, right? Still 3 lines of code, right? 1, 2, 3, 1, 2, 3, right? Same thing. The only difference between these two methods, in fact, I should just also do this real quick. Let's just encapsulate this within an if statement. like this, and then I probably just want to use an if statement here. So let's do if this, actually, if it is successful, rather, then let's do this, and then take this out, paste it in here. What do I want to do? If it is successful, actually, how do I check if this is successful? Well, if it's less than 0, actually, then it's not successful. Then we can just return false here. But then if it is successful, we can just return the file size, right? And then return true, like so. Yeah, so what is going on, right? I just restructured it to look the way I want it to look, but it's still just 3 lines of code that you're calling, just like you're calling here. It's just that I structured it within if statements and stuff, right? So this method, well, let me comment this out so you don't get confused. This method, right, gives us the file size, but the only difference is it doesn't need to open the file to basically go all the way to the end of the file and then give me the size. No, it just uses this method, which just gives it the file metadata, and then we're using that metadata here to just give us the file size, right? In fact, if you just put here, it's going to say this structure is used as the second parameter to the fstat. Wait, what? No. I guess it's not giving us the, wait, what? Number instead of the, okay, I don't know what this definition is for, but yeah, this will definitely give you the size. But yeah, okay. So you could use this method, right? And like I said, this method doesn't need to open the file, thus faster, right? And then this method needs the file to be opened in order to seek to end and then get size, thus slower in my opinion. Okay, but of course, if you're on the latest computers and all of that, the speed difference, I don't really think it matters too much unless you really have to, or if you have a very big file or something. But yeah, it's probably negligible, I guess. I'm not sure, but you can, yeah, you can quote me on that. I don't know. So this is up to you. If you want to use this is a little bit more platform specific because we're using the stat library. So we could do, it's not portable. Well, it is portable, but I mean, Windows does have this, I believe. Yeah, I think you just annotate or prefix it with this, so it's still portable to some degree. So yeah, guys, it's up to you which method you want to use. I'm gonna keep both of them here, and just comment this one out, but it does the same thing as this, so I'm gonna stick with this just so that it's a little bit more portable, I guess. So yeah, and then what we want to do is populate this function to read a line. Is my video still recording? Yes, it is. Okay, so how am I gonna fill this one out? I guess it's not gonna be too complicated, because all we're gonna do is use, I think it was in here, fread, no, yeah, no, get, this is used to get a single character, used to get string. The one that I'm looking for was fgets, which is this one. This function is used to read strings from files, and we're gonna use this to read a single line. All right, so yeah, let's get to it. So let's do some sanity checks first, because we are passing in way too many stuff here which we need to check for. So we need to ensure that all of those things are valid. So let's check if the handle is indeed passed in, and then if the max length is also passed in, along with the what is this, the line buffer, which we're going to use to essentially store the data to. And then we also want to check if the out line length has been given, and then once that has been given, we just want to check if all of this is actually greater than 0. And then if that's the case, then everything is valid. And then we're gonna do const char buff, an internal buff, which is just going to basically take or start wherever this buff starts. So we can just say it's equals to line buff, like so. In case, and in fact, I'm just gonna do this so that we know it's internal. And then outline length. What is this? Space. Wait, what? Huh? Ah, yeah. Okay. Yeah. And then all we gotta do then is use this fgets function. Okay. So we're gonna do if fgets the s. We're gonna pass it the buffer, and then it's gonna store that into that buffer, and then we're gonna do the max length. Then we're gonna pass in the file. I'm just gonna pass or cast it, and then we're gonna say file handle, like so. And then we're gonna check if it was successful or not, and then yeah, so if it was successful, then all we do is just pass out the length of that line as well. So we're gonna do string length. Oh, I might need to include string, I think. I'm not sure. String.h, because I'm gonna make use of string length to get the length of that line. And then I'm just gonna give it the buffer that contains that line. And then I'm gonna do this. And then I think, yeah, once we're done here, we can just return true. Okay, like so. And 1, 2, and then we're out of here. And then if none of the arguments that we need were passed through valid, we can just return false, because, well, what is there to do really? And that's it. This is all we use to read a line. We just use the fgets method to read a string, and that's it. So very simple, isn't it? So it's not that complicated. And then now we need the ability to write a line. So this will be different. Instead of using these gets, we're just gonna use the puts. So if you just do like how to write a line and see a line to a file, I guess. Adding a line to a file. Let's see what they use. Let's see what stack says. fputs. Yeah, that's it. Really. So those are the stuff that you're gonna use. So in our way that we're gonna do it is we're gonna do some checks again. We're gonna check if the handle is indeed valid or passed in. And then if that's the case, all we want to do is then use the fputs and the fputs essentially. The fputs returns a value, so it returns some result. So I'm going to store that in an i32, and I'm going to call this a result, and then I'm going to do fputs like so, and then we're going to put the text that we're passing in, and then we're going to basically file. So it wants a file, so we're basically just going to cast hold on, the file handle to a file type that it needs or supports, and that's it, right? Just takes in 2 arguments, right? Fputs, right? The line that you want to basically or the text that you want to basically put to, and then the text that you want to write, and then the file that you want to write to. Yeah, so that's it, really. That's all we need to do. However, I'm just gonna do an extra step here, and I'm gonna check if we are or not at the end of the file. Okay, and then oh, I think this is spelled wrong. This has to be EOF. Okay, and EOF just expands. Well, I was hoping that it'll give you the definition of this, so I guess I'll jump to it. Size of buffer is used by this. Yeah, yeah, I don't know, but it's, yeah, we're just checking if you're not at the end of the file. And then we're just going to put the new line character. Okay, so f put c, I think we just do like this. I'm just gonna put a new line character there. And then I'm gonna do file, cast this to file handle, like so. Just gonna put a new character line at the end of the line. Yeah, because we're writing a line, right? So that's that. And then we want to return, right? So we're going to return the result. So return result, and then we're going to do ELF, like so. And then if our handle did not exist, then we're just going to return false, because there's nothing to write to, right? However, I think here we can just flush. And it wants a file, so file, and then we're just gonna say file handle, like so. And what does this do? Well, if you think about it, when we call this function, we're writing to a line. We're writing a line to a file, right? But we haven't closed that file, right? So let's say, for example, now you write some line, and then somewhere your app crashes, right? You did not save anything, right? And therefore your data will either be corrupted or it will not be saved or whatever, right? So when I'm calling the flush, what I'm doing essentially is I'm just flushing the stream so that it's written to the file immediately, so that we don't basically lose any data in the event of a crash. Okay, so this just simply prevents data loss to some degree, right? Okay, so yeah, yeah, the flush. I don't know why they call it flush, but yeah. Okay, so now we can write a line, we can read a line, we can write a line, we can open a file, we can get its size, we can close. All we need to do is have the ability to read a chunk of data, essentially. And this one should just be simple as well. So I think it was here I was reading about it. Here it is. fread reads data from the given stream into the array pointed to. It's commonly used for reading binary files, but can also be used to read text files as well. The int accepts 3 parameters, so you guys can just read about it there. And then yeah, that's about it. That's what we're gonna use. So I guess you could just say we're wrapping because we're just going to be using that function called fread. We're just sort of wrapping and creating our own function around it. So yeah, so we're going to do if file handle does exist and the out data also exists. Out data does exist. The out bytes is optional. But yeah, so if the out data does exist and the file handle does exist, then all you want to do is just say out data, and that will be the out bytes. Read will then be equals to fread. Okay, and fread takes in the pointer, and this one will be the data. So basically the data, and then we're gonna basically say the size. I'm gonna say this is 1. Because where is it fread, okay, they said an integer and then they said 5. We're gonna just say 1. Yeah, I'm gonna say 1, and then I'm gonna do data size here, and then because they're passing in the size, well, I don't know what they're doing here, but okay, fine. But this is how I'm going to do it. And then what did it say? It wants the file, so file, and I'm going to say file handle like this, and that should just read the data that we want to read. And then we're going to do some check here, and then I'm going to say out bytes read, right? We're going to check if this is not equals to the data size, okay? And then if it's not, obviously, then we did not read everything that we needed to read, right? And then we can just simply return false. Yeah. And then from there, if we did manage to read everything that we needed to read, then we can just return true. So return true. Otherwise, if the file handle did not get passed through or is not valid or anything like that, we simply just return false because there's nothing to read from, right? And that's it. So that's the read function that we are going to use. And then we need the ability to read all of the data in the file, because we don't just want to read like from here to here or something like that. Sometimes we just want to read the entire file. So this is what we're going to use to do just that. So we're going to have two file implementation. One is for getting the bytes, and then the other one is just for the text. So the way that we're going to do it is going to be the same for both. Just the only difference is one is going to take, or is going to give out the bytes, and the other one is just going to give out the text. But in the end of the day, it's the same thing, really. So yeah, so we're going to do a check. I'm going to do file handle. I'm going to check if that's passed in, and if it is, then we're going to do if the out bytes is also passed in. And then if that's passed in, we're also going to check if the out bytes read is also passed in. And then, well, I guess since we are kind of using this here, out bytes read, right? Does that matter though? Yeah, we'll just put it there, I guess. But it will anyway be passed in, because I have to pass something, right? I can't just say null. Null is 0, so yeah. Okay, it's fine. Then what do I want to do? File out bytes read. Oh, okay, so we read all the bytes. But in order to do that, we need the size of the file, right? Because we want to read everything in that file. So what we're going to do is going to have an internal variable, and going to call this size of file, and I'm going to do 0 here. And then all you're going to do is you're going to get the file. So we're going to do file system size. Wait, file system get file size. Then we're going to pass in the file, and then we're going to populate that size of file variable, and then that's it. That's how we're going to get the size. And then if we failed to get the size, we're just going to return false here, because we failed to get the size. And if we failed to get the size, there's no point in attempting to read everything from the file, because we don't know how big the file is. So yeah, but then if we did manage to get the size, then obviously all we're going to do now is just say the out bytes read is equals to f read. So now we're going to use the same function we used before, but now we're actually reading everything instead of just reading to that size that we've basically passed in. We're just going to pass in the entire size of the file. So to do that, we're just going to say out what is this? Out bytes. So we're going to do out bytes, and then we pass in the size. This will be the size of file. So, and then it's going to take in the well, actually I made a mistake. The size, wait, f read. I'm going to pass in 1 because I passed in 1 there. Then I'm going to pass in the size. So that will be size of file. That will just give us everything in there. And then here we just do the file that it needs. So file, handle, like so. Okay. And that should be it. And then once that is successful, we just return the out bytes read equals to size, whether or not it's equals to the size of file. Okay, because if it is equals to the size of file, that will be true. If it's not, then it will be false, right? Because here again, I'm saying if the out bytes read is not equals to the data size itself, then obviously we did not read everything. So here as well, we're just saying if we read everything, then this should be true, therefore we'll return true. If we did not read everything, then obviously it's false, right? So yeah, so read all the bytes, and that's about it, really. And then if the file handle did not again get passed through, all we do is just return false, and that's it. Right? And then all I'm gonna do is just copy this bad boy. I'm gonna come here, then I'm gonna save, and instead of saying out bytes, I'm gonna do out text, and this should say out text. I think that's it, really. There isn't any change that I'll make here. Yeah, right. Yeah, that's it. So let's test this and see if it works. Now let's go to the main.c file, and we've already included this. So let's do this. Let's do how do I want to do this? Let's do file, because that's our way of using files. Then we're gonna do FileSystem open a file. Then we're gonna open the file that we want to open. Now I've already included a file. I just edited before I started recording. And then this is the data we're going to read out of this file, and then we're going to display to the console to test if everything is actually working properly. So just add a file in your root folder called whatever it is that you want to call it, and then just add whatever text that you want to add to that file. So that's the file that I'm going to try and open. So I'm going to pass in test file.txt. And then this is going to take in the file mode. So I'm going to say file mode read, and then the out file. This is just the handle we want to populate. And then this would open the file for us, right? And then once we have the file opened, in fact, let me test that real quick. So let me clear my terminal, and then let's make. And then it should compile everything, and it's not crying saying that the file is not found or anything. So I want to see if I make a typo or something, if it'll cry. And then yes, it does. So it says error opening file test full. Okay, so let me put that E back there, and then close my window real quick, and then make this. And then it should work, right? So it means that the file is indeed being opened. But however, I need to close the file immediately after. So actually, I need to do file like this. So that should close the file, right? But now, before closing that file, we want to do some stuff, right? So we want to test to see if the system actually does work. So what I want to do is I actually want to get which one do I want to test first? Let's read the whole text, right? Let's read everything in the file first. Okay, so the way that it's gonna work is we're gonna say file system read all text, and then we're gonna pass in the file handle, then the out text. So we need a buffer to store that text. So the way I'm gonna do it, I'm just gonna say char text content like this. If you guys can hear some noise in the background, I apologize. There are people outside my window making a noise. Yeah, so I'm gonna have a chart to store the content, and then I'm gonna need to allocate memory for this, and for that I'm gonna need the size. So I'm gonna create a variable here. So u64, let's just say size, and then I'm gonna populate that using the file system get file size. So we're gonna get the file size, right? So this file size, what does this take again? It takes in the file handle, so file handle, and then the out size, which in our case is going to be size. Um, and then once we have the file size, we can then allocate this block of memory to be the same as the file, right? Because we're going to read everything from that file and want it to fit in this block of memory, right? So I'm going to do malloc size of char, and then just multiply this with the size that we just got, right? And not to confuse you, let's just say size of file. So duplicate this, save, copy, save. Right, so that will just give us the size of the file, and then we're going to use the size of the file to allocate the text content here to be equals to that file, so that the size is actually the same, or can contain everything that we're going to read out of the file that we want to read out of. Yeah, I'm tired actually. Yeah, it's about 10, so I'm not thinking properly, or I'm not explaining properly, I guess, but oh well. And the other thing that I want to do is pass in, what do we need? We need the text. Oh yeah, so this is where we're gonna store the content that we're reading, and then all we need to then pass in, we don't have to pass in this, so we can just do 0 for now, because it's nothing really that we're testing, but we can just pass in the file size. It will just override that. It's fine. And that's it really. So now that we have the content, we can actually print this out. So let's do a debug print. In fact, not a debug, but let's do info. No, let's do, I want a color that will stand out. Let's do warn. Okay, and then warn here, it'll be the red content, and then I'm going to do a new line here like so, and then the content will go there, and then I'm going to say text content like so. And if I save and run this, it should work. So let's make, and yes, it does. So it says the red content is hello from text file. This is the second line, this is the third line. So if you look at that test file, indeed it does say hello from text file. This is the second line, this is the third line, exactly how we want it to look. So now that we know we can read all the text, we can essentially maybe test if we can read a line. So what I'm going to then do now is, let me see, is there something I want to keep here? Yeah, we can read all the text, so I'll just delete everything and just code as I go. Right, so now we want to read a line. So the way that I'm going to do this is I'm going to say file system read line, then I'm going to pass in the file handle, and then the max length of our line. I guess this can be the max length our buffer can hold. So if, for example, we had a child buffer here, so let's do buff, and then let's just say we can take about 256 characters, right? We can hold 256 characters, and then we can just do this like so, initialize it, and then because we hold 256, we can hold one less than that, so our max will be one less than that, so 255, and then we can then pass in the buffer that we want to store this line to. Now because this is now an array, I can simply just create a char pointer, right, and that will just point to the beginning of that array, and then I'll just do buff, and then the beginning of that array is at 0, like so, and then we're going to use that pointer to essentially populate the buffer, and then I just do at the pointer that we want to populate, the buffer that we want to populate, and then the length. I guess we could just store this, so we can do u64 line length 0. And again, if you guys can hear the background noise, I apologize. I have zero control of my housemates. Yeah, I'm a uni student, so unfortunately people don't sleep at this time, so yeah, I don't have a choice. Anyway, where was I? Line length, and this needs to be the address. That, and then I think this should work. It should then populate that. I'm having some weird formatting here. I guess we'll just split these for now. And then what else do I want? I now have the data, so I can simply just print out the line, isn't it? Right? So let's try that. Let's do debug warn. Line data is a string of. Now, do I want to say the buffer? Let's see if that works. So let's stop the program first, and then let's make. And then that should build, and then that should give us the first line, which it does. So now I'm going to duplicate these two like this, and it'll get the first line, then print it out, then get the next line, then print it out, right? So let's see if that actually works. So I'm gonna quit this, then rebuild, and then we should see two lines being printed out here. So we say the first line, yes, and then the second line, yes, it definitely gets printed out. And I'm seeing that we have a new line character here. I suppose, why is that? Read line. Am I? No, I'm not. So I don't know what that is for now, but yeah, okay, but it's fine. At least we know that it is reading line by line, right? And then we can actually automate this so that it just reads all the lines. So what I can do is I can use a while loop and be like while file.readLine. Then we can just do this, right? And then we can say line buffer like so. And then what I can do is to make this unique, I can say line, and then we can maybe use the line number, and then we can do, maybe we can have like a U64 to keep track of the line number, goes to 0, and then in here we can say line number plus plus, and then we can say line number and then the buffer, and then save this. So the line number comes here, and then the buffer itself comes here. And then if I run this, let me get rid of these first. If I run this, hopefully it should work. So let's close our window real quick, and then make. Does that work? Yes. So line 0 says hello from text. Line 1 says this is the second line. Line 2 says this is the third line. Does that check out? Yes, it does check out. I could offset the line to start at 1 like so, and then it should give us a little bit more accurate. So it will be a little bit more accurate, I guess. So line 1 is this, line 2 is this, line 3 is this. And when you open up your test file, indeed, you'll see that line 1 is this, line 2 is this, line 3 is that. So we basically tested that our file system works, right? We only tested the read line and the read all, but I suppose the others also work. And we've also tested the ability to get the file size, and that also works. And if you're still curious about that, let me just show you what it's giving out particularly. So let's do a U64 and then size, and then just do file system get file size, and then I'm going to do at file, and then the variable I want to store the size at, and then I just want to print out that variable. So let's do warn. Let's do file size, and then do the file size, and then just pass in that, and then you should see the file size being printed out to the screen, and then I'll show you if it really matches up or not. So yeah, so it runs, and then it's gonna say file size is 67 bytes. So if you go to your file, then you just right click on it or something, and then you'd be like reveal in Finder. You'll see that it says 67 bytes. right? And this matches up with the number that we're getting in the console here. So it means that we are indeed getting the correct file size. So yeah, right? So maybe we wanted to get the file size of the make file, so we can maybe go back to the main and then be like, instead of test file, we can just say make file. Make file doesn't have an extension, so if I rerun, if I reboot, it should give us the size of the make file, and the size of the make file is 1232. I guess now it's kilobytes. And if we check for that, let's see, make file, get info, or reveal in Finder, and then it'll say 1 kilobyte. And I don't think this will give us any. Yeah, it does. So here it is. So 1232, and down here we have 1232. So it is accurate, right? So yeah, that's it. So everything works. And ladies and gentlemen, that is it for this video. If you enjoyed this video and would like to see more, definitely hit that like and subscribe button, and I'll see you guys in the next video. Take care. Cheers.